All right, hi everybody. We've been trying to export some open source models and just to show you guys how the typical workflow for exporting a model might look like. So today we have Tugsuu who's going to show us how to do it on a model he selected.
Yep.
Take it away, Tugsuu.
Yeah, so today we want to look at this model called parameter flow. It's been like rising popular lately, and I just want to talk about so this model is basically, and you can there's like two modes of operation. One is like you have a text, you give a prompt, and you get a video out of it. Another option is like we have an image, and then you kind of the model can like extend the image to a video. And today we will focus on the image to video section because I thought mostly that that's probably like more cool than text to video. So unfortunately this link is down. So like you cannot really see the video on their GitHub page. But in general, the flow is like they use flow matching algorithm to do training, which basically means like instead of trying to create like a full resolution video at every denoising step, they try to like do use flow matching so to like not generate full the full resolution images at the lower like when there's no so much noise. So like I guess they like create more like full resolution when it gets close to like not very noisy part. So I'll skip all the boring stuff with like installation, downloading the models from Hugging Face and all that stuff. And this is like a simple script I put together based on their app.py, which is like so like in their own repo, if you run this app.py, it will launch like a web browser link and where you can like put like kind of change the parameters to see like different kind of videos. But just to make it simpler, I just kind of copy pasted this code and like make it not rely on any like web related things. So it's just strictly just exporting a model. So there's like a generated image to video which takes in like an image and then it just creates like a movie out of it. So I can show you like basically how it works. So let's say like so in their own repo there's like a gradable which you probably guess is just like uh just the image of gradable of China in China and then I'm just saying okay just can you make a movie out of this? Um so you can do like, so this is like, I was just playing around with like different steps. So this kind of indicates like how big, how long your video should be. So let's try like a little longer video, maybe like 10 and like 384, it's like kind of bad. So like let's try 760. I think 768 is allowed amount.
So
Yeah.
does 10 mean 10 seconds?
I don't think it exactly means 10 seconds,
Okay,
but I think it's like 10 frames or something. Yeah.
I see.
So let's just try running this. So as you can see, I'm not really using any, well, like ignore this part. So like this, I'll get to this later, but I just commented out all the like export related things. So now it's just strictly running eager code. So it'll take some time. So when it's done, we will get at this video. Maybe 10 was too long. I should have done 4, but we should see a longer video just to just to demonstrate like how
Yeah,
cool the model is. Yeah.
cool. So maybe do you want to take this time to kind of walk us through the model itself a little bit? Just to,
Sure.
yeah.
So I think the core, so a lot of these inference models have this concept of pipeline, which basically means like it takes all like the prompt or like an image, all this like hyperparameters, and it just does the magic to figure out video. So I guess we can just get started with like looking into what this generate I2V method does. So
Mhm.
this method basically takes everything we need and then just create a video out of this. So you go here. I think it was here, generate I2E. So I'll skip this CPU uploading stuff just to make it simpler. Um, so basically we like kind of process the prompt. Basically it's saying, okay, like we want to create, you know, very good quality video. And there is like this negative prompt which the model uses to like avoid creating. And
Mhm.
I think a lot of these models use like this like a positive prompt and negative prompt to like fine tune the model. So there's this like text encoder which takes the prompt and negative prompt and creates some like tensor embeddings that can be supplied to the main chunk of the model. And then like I will skip all these things and then you could just do some processing on the embedding tensor. So if you're using like multiple GPUs, there's like distributed stuff. Then you create like based on this, you create this another like processing step to get embedded in. So like right now we're not really doing anything like a tensor heavy. It's just like shuffling tensor around, right? And then we figure out like how many stages we want to do. And then we like for num units is like basically like this number. So like for how like so it's kind of doing it in the loop. I guess it kind of makes sense, right? Because you create an image and then you create the next frame based on the previous frame. So
Ah,
like that's
yeah.
why you kind of have to do it in a for loop fashion. And then you do this all this like processing just to figure out like where to like start a tensor and stuff, right? And then there's this important method called generate one unit, which means like you create one frame based on like all the past frames you've seen.
Okay, so this is inside the bigger loop that you have.
Yep.
Okay.
So inside a generate one unit, there's like, so I think the whole point of this is like you create one frame based on the past frames. So it takes a bunch of inputs and then, so there's this like so it's like a diffusion based model where like basically what it means is like you start with this like very noisy
Uh-huh.
image and then like step by step you like denoise it into like something proper. Um, So they self.dit, so this is like the main pyramid model they use to create the like denoise or like the generated image. And then so if you so basically the whole chunk here is like you just like based on the input you create an output, tensor output. So if you go back to here, we are still in this like big for loop where you create a unit. And then in the end you decode the resulting tensor into something we can understand as an image, and then you return this image tensor, and then there's like uh generate I to export. So in the end, so you basically get this like frames of like images.
Yeah.
Then you take this images and the video pen and create a video.
Okay.
So I think it's done now. Export image
Yeah.
to sample. Um, so basically it's kind of like just extending this.
Yeah,
This
that's cool. Some
pretty cool.
car almost went out of the wheel.
Yeah.
Okay, that's cool. Okay.
So basically the model is it's kind of cool that you're like you can set this up locally and run it without like,
Yeah.
relying on the server. So now we can talk about like some strategies where you can use to export.
Mhm.
So as you can see, like the this, so I guess like the your natural instinct would be like, okay, like I don't want to care about like all this model code, so I just want to like plug in like like just like torch compile, we just plug in torch export on this and just figure out just get some artifact we can run, right? But
Mhm.
the problem is like export unlike torch compile, well, I guess like for torch export, it's like it's only supposed to work on like a dynamic tensor inputs. So like if you directly pass in like texts, it's not gonna work well. And I feel like the justification we can see here is like export is mostly for, like using like custom hardwares to like accelerate the model, right? So like we should really focus on like mostly exporting like super heavy chunk of the model code instead of like spending a lot of time, trying to like. So basically, what I'm saying is like if it's probably not that much value when we like try to export like this like pre-processing logic.
Yeah, that makes sense.
Yep. So as I like briefly mentioned through before, there are like kind of three big chunks in this model, right? One is like text encoder where like you text take the prompt and image to like encode it into like some representation. And there's another like DIT diffusion-based model. Like this is like the core of this multimodal
Mm.
example that which takes in like a tensor input and then created some kind of like encoded tensor value. And then there's like a decoding step where you take this like output of this into this decoder step to get like a image. So I feel like the reasonable thing we can try to do is like for each of these model, we export them separately, and
Okay.
then rely on the pre-processing code, like Glue code outside. And this is actually what we are planning to do for our like Torch native based demos, where you like how we will showcase how you can export a model into like complete artifact. So like what I'm saying is that basically all this glue code around model processing should be implemented by the user or like outside of export.
Okay.
So we can do like so just to make this faster, I'm just gonna lower so this basically will create like 1 second video and then I'll just lower the resolution so it's easier to iterate on. So torch export is basically if you look at torch export API, it requires example inputs.
Yeah.
So I wrote this like a simple glue code where you like wrap the model forward method with a wrapper which kind of like listens to the model which kind of like listens to the sample inputs and then you use the sample inputs to export. So we are currently in the process of like writing new util methods which utilizes basically builds on top of this idea where you like export will listen to like example inputs while you run the inference loop. And in the end, we use export. In the end, we use like this example inputs to export a model.
I see.
Uh,
So let me just like try to like replay to you what I understood here. So
Mhm.
basically you have the eager model and you are going to sort of like wrap it so that we intercept the inputs that
Yep.
are passed to the eager model and then you're exporting. So presumably you don't want to do it actually at inference time, but if you had like test cases or whatever, you could potentially use this wrapper, right? And then automatically get example inputs for free.
Yes. So uh, basically, it's not recommended that we just hijack like
Yeah,
inference loop with export code. This is mostly for since this tool is still under development. Like I just want to like kind of
that makes sense.
what our general direction is.
Yeah.
So that's why in this test case we are like hijacking the eager code,
Yeah.
which is like so you in general you can imagine something like export like listen to input and then create some artifact and you use that artifact later, right?
Yeah.
So let's just like do partial export uh so um basically what I'm trying to do here is like there's like text encoder. We are using Flux-based text encoder, and then there's this like an NN module which has like two encoders inside. So
Mhm.
this model has like two submodules. And the reason we are not like directly trying to export this model is because the forward method here takes an input prompts, which is like a list of strings.
Mhm.
So like not really suitable for export. So, but we can from this code you can see like there is like two like actual models we initialized, right? So like basically we're trying to export them separately.
And so the inputs to these submodules would be like processed information,
Yes.
processed tensors. Okay.
Yes. So I think these models are coming from Hugging Face library.
Mhm.
So all the Hugging Face library models have their forward is like, like processed in a way that it only takes in tensors. No, it doesn't take like, because like Hugging Face usually relies on like a generate method to like create a output. So we can see how it does. So now you should expect to see like, very short video with like kind of low resolution because we kind of lowered it. And right now we are only exporting like the encoder part.
Okay. So cool. So again, just to reiterate this point, you basically are using the same script that you used to run the inference, right?
Yes, yes.
And but the difference now is that you have sort of hijacked just these submodules so that whenever you're calling it, you're first going to export it and then you're going to run that
Yep,
part.
yep, yep.
Yeah.
So it created, so it's like very short video, but I mean you can see still like the image is moving, right? So next step is the IT part where so let's try. So now we are like exporting the encoder part. Now we are also exporting the main chunk of the model.
Mhm.
So one thing I kind of wanted to highlight here is if you look at generate one unit, so this is the step where you're using like it's like a diffusion based step, right? You start with like this noisy input and then you like
Yeah.
gradually make it into a proper image. So note that we're not actually exporting all these things,
Hmm.
really, but we are exporting like this part. The reason is like diffusion models, like this step is inherently very data dependent,
Hmm.
very runtime like value dependent. So it's like it's not really suitable for export directly. And frankly, like this step is like not very expensive. So I feel like even if you try to export it, you won't get that much value out of it.
Hmm.
So that's why we're inherently like skipping
But in
this.
principle, the number of stages is a constant. So we might be able to just like unfold the loop a bunch of times, or you have to use a sort of like a control flow op or something to
So
model the iteration.
so I think this part is fine. The main problem is this sets
I see.
times.
I
So
see.
this part is very like data dependent.
Yeah. Okay. Makes sense.
So like for our Torch native demos, we were planning to do some like, diffusion based models and there you can actually see how you can like in production cases how you can use reuse it in C++ plus plus or like any backend.
Okay.
So you saw that um we like basically did the main loop, main model, and then you can still like see
Yeah.
like export is working fine and creating a result you want. And then now like so this is kind of the easy part. So like the main chunk of the work is being done here.
Yeah.
And then this is just like a decoding into an image. So
So could you explain this dynamic shapes callback that you passed to did?
um it's also just like for experimental purposes. So point is like if you look at my script, uh if you look at my script, we have like basically we like try to cache the exported tensor no, sorry, explorer program, cached explorer program so that we reuse the value.
Mhm.
So for this, like, if you just create like a static shape, then it won't work, right? Because if the input shape changes, then it will work, it will fail.
Oh, okay.
Dynamic shapes callback is basically I'm saying like, okay, um, like user me specifying the dynamic shape. So it's like we don't have the infra for like I haven't implemented the part where you actually like kind of collect all the tensors,
Yeah,
all
yeah.
the inputs into one. Yeah.
So I think I noticed that you basically take all the args and make them all dim auto or something.
Yep.
Yeah. So dim auto for people who don't know is like a very easy way to just say, okay, I mean, I'm not going to force you to use static shapes. if you infer that your shapes must be static, then make them static, otherwise make them dynamic.
Yes, yes.
Yeah.
So in this case, like I don't know anything about this model, right? I just looked at it yesterday. So like
Yeah.
most basic thing I could try is like
Yeah.
auto and then
Yeah. So this is a good tip for people who are not supremely familiar with the model code. Uh,
yep.
so this is kind of like most general kind of shapes that you can use.
Yes, yes.
Mhm.
So you can see like that we are still producing image to video.
Mhm.
So I wanted to make it a longer video, but like if you when it starts like when when the time steps long gets longer, like the export process is like pretty long. So it takes some like at least like 5, 6 minutes to actually run. So I'm gonna just like skip this part and show you what I produced before this video.
Okay.
Yep, that's all. So as a next step, in part two of this video, I'm planning to um go like go further steps and then how you can use like AOTI AOT inductor to like create like a more single runnable binary in the end. So that would include like stuff like rewriting all this like diffusion based time steps into like proper C++ code so you
Okay.
can create a one giant binary to run. Yep.
So an exported program, okay, after generating the bits of exported programs, you were running them, right, to get the.
Yes.
Okay, so those, so you have mental model is you have some Python code that is driving these submodules which you have just exported, and the regular interpreter can just run an exported program because it's just an fx graph underneath.
Yes. Yes.
So when you go to a inductor, you don't necessarily want to have the Python driver running the generated artifacts, which are like all C++. You want everything to be C++ or what?
So I think there are two steps. One is like you can just use normal like AOT inductor to like have Python. There's like a Python driver code can still be there, and then you run like AOT
Yeah,
inductor specialized code. The other, if you want to go even further,
yeah,
you
yeah. That makes
want,
sense. Okay,
yeah,
so as long as you have that flexibility, because
yep,
during iteration you might still want to have some Python driver code. Okay,
yes,
cool.
yep,
All right. So yeah, so we'll see when we can record the part two, but
yep.
this should give a nice flavor of um, how it is to explore model. So you didn't necessarily know everything about this model before, right? So you basically picked it up, maybe studied it for a while, and then started exporting it.
Yeah. So like so my point is like so like Hugging Face is like like heavily Hugging Face works with export Torch PyTorch quite a bit. So I just want to pick a model that's like not really in Hugging Face. It's like some random model I saw online.
Yeah.
And
So over time, if we build up sort of more examples of this kind, hopefully we'll see that the workflow kind of converges, right? So for many Hugging Face models, you'll typically follow the same workflow, and it should work.
yes, yes. So like I think the main takeaway from this video is like compared to Torch, so Torch Compile can graph break. So like that way you can that's why you can just like slap a torch compile on anything and you can expect some improvements, right? But for export, it's like full graph or nothing. So what I'm trying to say is like you shouldn't try to export the whole thing directly.
Yeah.
Instead, you should focus on like the core parts that you want to optimize further, which
Yeah.
is usually like like the submodules that does the heavy is that are doing the heavy lifting. And all this pre-processing stuff should happen outside of export.
Okay. Cool.
Cool.
All right. Thanks, Tugsuu.
Thanks.
All right. Bye.